People love to play video games on old game consoles, but today we cannot play those games in the same way because these consoles are no more for sale. And to solve this problem, a new class of programs is born, and those programs are called emulators. So emulator is just an ordinary application. You install it on your PC, you add retro games to it, and then you can play them. So for video game, it doesn't matter if it is played on original game console or it is played through emulator on a PC, because emulator is used to emulate those old game consoles. Now, in the same way as we can emulate all game consoles, we can also emulate the whole computers. So I will go here below and I will tell you that it is possible that in one computer case to install several operational systems with all of their applications and then to use them all together at the same time. So how is this possible? Well, again, we need an emulator. An emulator for operational systems is called hypervisor. And an example of such hypervisor, we have VirtualBox. And here we can see a graphical interface of VirtualBox. So VirtualBox is just another application, just like an emulator. Inside of it, we can create so-called virtual machines. So virtual machines are software-based emulation of physical computers. So we can create several virtual machines. We can install inside of them operational system and its applications. So we can use all of them at the same time, just like they are some kind of normal applications. Each of them will have its own window and we can use them all together in our desktop environment. We can also notice here that on our PC we still have to install one main operational system, and that operational system is called host operational system, while operational systems inside of virtual machines are called guest operational systems. But today we are talking about Docker containers. And the best way to describe containers is to say that containers are in between portable applications and virtual machines. On the one side, we have portable application. That is application that doesn't need installation. It should match operational system version. It is lightest and fastest, and it is not isolated from other applications. For example, two applications can share the same resource and they can fight over that resource. On the other side, we have virtual machine. Virtual machine is full operational system with all of the applications. A virtual machine should match hypervisor. So virtual machine that is working on VirtualBox will always work on VirtualBox no matter where that hypervisor is installed. Virtual machines are heavyweight and they are fully isolated. And in between we have containers. Container is application that is packed with all of its dependencies. Container should match class of operational system. So we have containers for Linux and containers for Windows. Containers are middleweight and containers are mostly isolated. And we can see that container is stripped down virtual machine. So here on this image, I have one virtual machine. This virtual machine has guest OS, and guest OS has API and kernel, and it has several applications. But if we remove all of the applications except one, and if we share the kernel with host OS, so instead of having separate kernel for each virtual machine, we can have one kernel in the host operational system and all of the containers will use that kernel. In that case, we can create one container. So container is just one application with API that is using the same kernel as host operational system. Now, containers do not use hypervisor, they use Docker Engine. And Docker Engine is an application that you install on your computer, so it is similar to VirtualBox, just it is Docker Engine. Now, we said that containers are similar to portable application, so they are easily deployed, moved, and upgraded, and also they are isolated. On the other side, compared to virtual machines, containers are much lighter and faster, and containers are immutable. That means that we cannot change parts of our container once we create that container, and that will give us consistency. So we can be sure that one container will always work in a way that is predicted to work. The life cycle of container starts as an image. Image is a template or prototype based on which we can create a container. And this image is made by application developer. So application developer will create an image. So image is something like installation file. And that image has to be provided to a user. So developer can send this image to a user, and then user can create a container that is based on that image. Here below we can see the whole life cycle. So first we have this part that has to be done by application developer. Developer will use all of the source code of his own application. He will add instructions in this Docker file how to create an image, and with build command the application developer will create an image. This is Docker image, and usually that Docker image is then sent to some registry. Registry is actually a repository with many Docker images, and the most famous one is Docker Hub. So this is in cloud registry of Docker images. Users can use pull command to get images from the Docker Hub onto their computer, and then based on that Docker image, user can start a container, and inside of container there is an application that user can use. Let's now see what is inside of a Docker file. If I follow this link here, I will land on this GitHub page. And here we can see all of the files that are needed to create an image for MonetDB. So most of these files are source code files for MonetDB, but we also have this Docker file. I will open this Docker file in a separate tab, and here we can see the Docker file is just a list of steps that are needed to create our image. And this Docker file has a lot of steps, so I will show you one more simpler Docker file. I will go back to this web page, and let's assume that we have a web application that is made with Node.js. Node.js is a framework for making web applications, and we want to create an image based on that application. So we would use this Docker file. First, we will get some base image. Base image is a Linux API. In this case, we will use Alpine distribution because Alpine is one really small Linux distribution, and this is not the whole distribution, this is just API. And this Linux already has Node.js installed. Now, how will computer get this Alpine Linux? Well, it will download it from the Docker Hub. So all of those base images are on the Docker Hub cloud. Then we will define a working directory inside of this Alpine Linux. We will copy files from the current directory to current directory. This first current directory is on our host machine, and this second current directory is actually this working directory on the Alpine Linux. Then with those files, we also have a file that has a list of all of the dependencies. So dependencies are libraries that are needed for our application to run. So we will then start this command inside of our image, and this command will install all of those dependencies from that list that was inside of these files that we have copied. At the end, we have a command that will run when our container starts. Next, I will show you a general structure of a Docker file. First, we have to always get some base image, then we define some folder, then we copy our application, then we download some dependencies, then we build compile, we create a user, we expose some network ports, we set some environment variables, and we define startup command. So Docker file is basically a list of steps that we would have to do if we would to install our application on a physical machine. But now all of those steps have to be done automatically, so we have to create a list of those steps in order for Docker engine to repeat all of those steps. I will not go deeper into Docker technology, we will now only see how to install Docker and how to download and use MonetDB container. We will now see how to install Docker Engine. I will first go to this link here. So in this tab, I will see an instruction how to install Docker Engine on Ubuntu. And this is really a long instruction, but we will take a shortcut because here at the bottom we have these two lines. This first line will download a script from the internet, and this second line will run that script. And that script will install Docker for us. So I will go now to terminal, and I will first download this script from this location. So I will run this. After that, I will run this script. So I will use this command. Now that our Docker engine is installed, I will also add my user to Docker user group. And in order for this to become valid, I have to log out and then to log in. So I will now go here to log out. And after that, I will log in. Then I will again open a terminal. And I will run command docker version. So this command will show me that I have successfully installed Docker Engine. I will clean my screen. Next step is to get MonetDB image. So we will not make that image by ourselves. We will go here to Docker Hub, and we will go to MonetDB account, and here inside of this tab tags, we can find different versions of MonetDB. So whenever a new version of MonetDB is released, a new image will also be made, and it will be placed here inside of the Docker Hub. We will not use these old images, we will use this latest image. So I will now go back to terminal, and I will run this command. Now this here is the name of an account on Docker Hub. So this is the name of an account. This is the name of application. So we need the name application, and then we need a version. And in this case, the version is latest. So this command here will get MonetDB image from Docker Hub onto our computer. So I will run this. And then I will run this command. This command will list all of the images that I have on this computer. So I will run this, and we can see only one image. So this is the image that we have just downloaded. This is ID of this image, and the size is half of the gigabyte. I will now clean my screen. We will now see how we can create a container based on our image. And for that, we will use docker run command. Our container will expose MonetDB on this port, but I want to tie that port for some other port on the host computer, and for that I will use the same port number 50,000. Also here I can type any number, so I can use any port number on the host machine. This is important because if we want to have two containers with Monet, we have to tie internal port of the container for different external ports. Then I have a command that is saying that when I restart my computer, that this container will automatically start. Then we have E option. E option is for setting some environment variables, and I will set this environment variable. I will say that my database password is MonetDB2, and then we have a name of our image. Now, how come I have a password for a database, but I haven't defined what is the name of a database? Well, in this case, we will use default values. So I will jump to this web page, and here we can see that inside of this environment variable we just have to define a password, but the name of a database will be MonetDB. This is the default name, and we will also create a DB farm on this location. So I will now go back and I will run this command. And this will start my container, but in the foreground. So we cannot use anymore this session here. Instead of that, I will open a new tab. And here I will type command docker ps. And this command will list all of the active containers. We can see that our container is running for 14 seconds. This here is ID of our container, and we can use this ID to reference container, or we can use this name here. So each time when we create a container, Docker will randomly create this name and this ID. Now we can connect to our container, and for that I will use docker execute command. So I will use docker exec, then it. It is for interactive. Then I will use this ID. So I have somehow to reference my container. I just have to use a few digits. So we don't have to type all of this. We just have to type a few distinctive digits. And after that, we have to call bash. So we will connect ourselves to bash inside of the container, because as we know, container has Alpine Linux inside of it. So I will run this and we will log in as a root. This here is ID of our container, and now we can log into our database. For that, we will use mclient. So I will run this command. Our username is administrator MonetDB. Database is MonetDB. This is default name, just like I said earlier. So I will run this, and then we have to provide password, and password is provided with this environment variable. So password is MonetDB2. So I will type that, and we are now logged in into our database inside of a container. I will now clear my screen. I now want to show you what will happen if I restart my computer. So when we have created the container, we use this option, restart unless stopped. If we do not want our container to start automatically when our computer starts, then we should use this option, restart no. But this time we will restart computer, and then we will expect for our container to work. So I will first exit mclient, then I will exit this session, and then I will reboot my computer. I will log in, and I will open my terminal. Inside of it, I will type command docker ps. This will list all of the active containers, and we can see that my container is active for 13 seconds. Also notice that my ID is now a little bit different than earlier, and this is because I had some problems, mistakes, so I created a new container. So don't expect that during this video ID will always be the same. It could change. Now that we know that our container is active and is working, I will show you how we can stop our container. For that, we use command docker stop, and then we use a few digits from ID, E1D. So this will stop our container, and then our container will not appear inside of this command, because this command will only show us active containers. But if we type docker ps and then a, in this case, we would get all of the containers, both those that are running and those that are stopped. So we can see that this is a stopped container, and when our container is stopped, then we can delete it. And for that, I will use command docker remove and then ID E1. So I will type this, and now our container is deleted, but we still have an image. So if I type docker images, then we will see our image, but the container is deleted. we can also use command docker container prune. This will delete all of the stopped containers. So if I run this, all of the containers that are stopped will be deleted, and in this case we don't have any other stopped containers, so this will not do anything. I will now clear my screen. Now that we have deleted the only container we had, we will now create a new container. But this time I will customize all of the options. So I will paste here one command, and we can see that command here. It has a lot of options, and we will now talk about all of these options. So I will paste here. I will create a new container. This is ID of my container. Now here I have used this option D. D means detached. That means that now my container will run in the background. So I don't have now to create a new tab. I can continue using this session. I will now clean my screen. In this new container, we customized location of DB farm and a name for our database. I will jump to this web page, and here we can see that this here is default location for DB farm. But I created a new location, DB farm 2, because I customized this location. With this environment variable, we can define name for our database, but we can at once create several databases. We should avoid using spaces here in between. In between names of databases, we should only have comma, and so I will create two databases with names DB1 and DB2. Both of these databases will have administrator with the same password, MonetDB2. I will now go to terminal, and I will connect to my container using docker exec command. So now I'm again inside of the bash, and I will try to jump to this newly created DB farm. So DB farm 2, so it is existing. So we have DB farm on this location, and if we read from content of this folder, we will see that now we have two databases. We have DB1 and DB2. So we can either customize these values, or we can use default values. I will now clear my screen. With docker run command, we have created a volume. I will jump to this web page, and we will take a look at this line. This here is directory on the container. But this is not really some folder with some content. This is just a mount point. And we have a directory on the host system that actually has data, and this directory on the host system is mounted to this point. I will scroll here down, and here we can see that this mount point is used to mount this folder from the host computer. On the host computer, this folder is controlled by Docker Engine. So Docker Engine will place all of the volumes at the same location, var lib docker volumes, and then the name of a volume. And this here is the name of a volume. So our data will be outside of the container. So I will show you that. If I now go back, I will open another tab, and I will open my file explorer with the name tuner. I will open it, and inside of it I will jump to this folder, and here are our databases. So our databases are inside of the host computer, not inside of a container. So now I can delete this container, but my data will be persisted. So after some time I can create another container, and then that other container can use the same volume, so my data will be available. So this is how we save our data with volumes. I will exit this, and I will go back to bash. Next we will talk about log file environment variable. So we said to Monet that our log file should be this one here, and we should save our logs inside of that file. So I will go back to bash, and I will try to read from this file, and here we will see our log. We also set some environment variables for snapshots. So our snapshots will be inside of this folder, and our snapshots will use this compression level. I will now go back to bash, and I will now try to create a snapshot with default settings for database DB1. So I will run this and this will fail because we don't have this folder already. So I will first create that folder. I must create it. And then I will create a snapshot by using the same command as above. And now snapshot will be made. I will now jump to this snapshot folder. And I will read from this folder. And inside of it, we will find our snapshot. In our snapshot, we'll use busy2 file format extension because that is what we defined inside of this environment variable. Now, if we do not provide these environment variables, we will not be able to create snapshots. And of course, it would be wise not to keep snapshots inside of a container, but inside of the volume. I will now clean my screen. I already show you that we can set some properties for DB and for a database. I will jump to this web browser, and here we can see inside of this blog post for MonetDB and for MonetDB that we have a list of the properties that we can set for DB and a list of the properties that we can set for our database. And today we saw that we can change those properties inside of the Docker run command too. I will now check whether these changes were successful. I will go to terminal and I will use getAll command to get properties of the DB file. I will only read values for exit timeout and for keep alive, and values are 70. So this is the same as inside of the Docker run command. In this way, we cannot set all of the properties. For example, property list and address is always set to all. Also, we cannot set properties control and passphrase because they are used to control remote access to a daemon, but with containers, we are using this environment variable to set daemon password, and when we set daemon password, then control property will automatically become true. I will now go back to terminal and I will now read my properties for a database. I will again use getAll command. I will run this, but I will get this message, incomplete response from MonetDB, and also I will be logged out. So we cannot read our properties in this way when we are using containers. There is some kind of bug. So instead of that, I will again go to bash and I will log in to my database DB1. And there I will read from one system function with the name env. My password is MonetDB2. And then I will use select query to read from this function env only for those properties where value is 10. So I will get these two properties, and the values are 10 because they are set inside of the Docker run command. So the values are 10 for these two properties that limits number of threads. I will now exit mclient and I will clean my screen. I will now talk about passwords. In Docker run command, we defined two passwords. One is for administrator and the other one is for remote control of MonetDB. Now, in the blog post about MonetDB, we saw how we can remotely control MonetDB that is on some other computer. But now we're talking about Docker containers. So in this context, we want to control MonetDB that is inside of the container from the shell of the host operational system. And to show you that, I will go here to terminal and I will not run my command here in bash, but I will go here to shell of the operational system that is host. And here I will use this command, MonetDB. I will target localhost. This is my password. So that password is defined here inside of Docker run command. And my command will be to create a new database. So I will run this and this is successful. Now, in order for this to work, we need to have Monet server installed on the host computer. DB farm must be running in order to have access to MonetDB application. And this server on the host computer must use different port number than the server that is running in the container. So in the container, we are using port 50,000, but here on the host computer, if we read port number of our DB farm, we will see that here we must use different port number. I'm using 50,001. I will now run File Explorer on this host computer. So I will run it. So my password is this. And then when my File Explorer opens, I will go to my volume because I want to see whether I have successfully created a new database. And here it is. So we have created a new database. I will now go back. I will stop this and I will clear my screen and I will go to bash shell. We will now see how we can stop and start a container. I will go to shell of the host system and I will use command docker stop. So I will stop my container, and after that I will list all of my containers and we will see that now my container is stopped. We can also start a container. For that we use docker start command. I will run this and then we will take a look at a list of active containers and we can see that our container is active from 5 seconds ago. Next, we will see how we can delete containers and images. In order to delete container, first we have to stop it. So again, I will use docker stop. And then I will remove it with the command docker remove. So this is how we delete the container. We can also delete images. First, we will take a look at all of the images that we have. We only have one image. And we can delete that image with command docker remove image. And then we should provide image ID. If I run this, image will be deleted. I will now clear my screen. We will now see how we can remove Docker engine from our computer. First, we will stop Docker services. And then we will remove also this other Docker service. And then after that, I will uninstall all of the Docker packages. After that, I will remove Docker repository and I will also delete GPG key that we used for Docker installation. After that, I will update index of available packages. I will now clean all of the orphaned dependencies. So I will use sudo apt auto remove and sudo apt auto clean. Then I will remove all of other files. So I will remove these files. I will also delete these files. And I will delete these files. Then I will delete Docker user group. And at the end, we can check what is the version of our Docker. And we will see that Docker is no more installed.